So for this power series, we're going to do a series ratio test. And first things first, we're going to need an a sub n plus 1, which is going to be our function x minus 3 to the n plus 1 over n plus 1. And then we have our a sub n, which is just going to be the same as our original function. So we're going to take the limit of n to infinity and the absolute value of a sub n plus 1 over a sub n. And once we simplify that, we're going to see we get the limit of n towards infinity, absolute value signs, and then we're going to have x minus 3 to the n plus 1 times n, all over n plus 1 over, or times x minus 3 to the n. And already we can see some cancellation, and I apologize, I crossed out that function of x minus 3, I didn't mean to. But then if we continue to simplify, we can then see we've got n times x minus 3 all over n plus 1. So then we can bring that x minus 3 out in the front of the limit. Don't forget the absolute value signs. And after we get that in front and continue to simplify, we can then see, we get those n's out of there, we can then see on top that's going to go towards 1 and on bottom that's going to go towards 1. And so then that's going to leave us with our x minus 3 and the absolute value signs, and then we can use this to find our convergence interval. We can take those 1 values and our absolute value of x minus 3 and some simple algebra, and we can then use that to find our interval, and that's going to get us 2 is less than or equal to x, which is less than 4. So then we bring that down. We're going to start with our x minus 2, and we're going to plug 2 into the original series function up on top. And then with some simplification, that's going to bring us to negative 1 to the n all over n. And I'm going to skip over really quick to x equals 4. We're going to do the same thing. We're going to plug that in to the original function up on top. And from here we can see that this diverges. And then going back to that x equals 2, we're going to do an alternating series test, get an a sub n, and set that equal to 1 over n. And we know that this limit will equal 0, which means that this is going to converge. And we're going to check the convergence too of this summation function right here from that x equals 2 earlier. And then with some simplification, we see that's 1 over n, and we know that this diverges. So then taking all of the information that we have from above, we see that this converges conditionally. So for the final answer, we've got it's 2 is less than or equal to x, less than 4 for that integral. And on the other side, we've got our true or false. about this power series, if it converges for x equal 2, then it must converge for x equals 1. So in order to converge, we know that it must satisfy r is greater than or equal to 2. So it must converge absolutely for the absolute value of x to be less than 2. And x equals 1 is well within that range of negative r is less than x, which is less than r, or in this case, we're going to plug 2 in for those values. So this is true.